How's it going, guys? In today's video, we're going to be going over unit testing in SwiftUI and how we can use it to make sure that the functionality of our apps is robust and will not cause many errors later. So to get started, we're going to be creating an app similar to this one. So essentially you have a value that you can convert, and once you tap on it, you're going to get the keyboard, and here you can go ahead and type in 90 and tap on convert, and it's going to change the value from euros to USD. And that's the only thing we're going to be doing, a very simple converter that's going to be built with robust functions and unit testing kept in mind. So of course you can go inside here and you can try to convert nothing, and we're going to get an error. And let's go ahead and try something else, such as giving 3 decimals. And if we try to convert that, it's still going to say, please enter a positive number. So we're going to cover all of the scenarios of everything that can possibly go wrong in this app and cover that through unit testing. But to get started, you want to go ahead and open up a fresh new Xcode project. So the very first thing we have to do is go ahead and create a view model. So go ahead and click on Swift file and create a new one of those. And we're just going to call it a view model for this example. And we're going to go ahead and first create a final class called ViewModel, which is going to conform to the observable object protocol. And inside here, we need to create a few variables for our app. So the first one is the text, and this will be preferably from the error message. And we're going to go ahead and create another @published var, which is going to be the converted text. And that's going to equal this empty string initially with the $sign and 0. And we also want to go ahead and create some functions that the user can use to convert the money. So the first thing we're going to do in here is create a function called convert money. And every time the user taps on this, it's going to convert the money for us. And inside here, we want to add the functionality that's going to convert the money. Another function I want to have in here is the private function of hide keyboard. So when the user taps on the enter key, it hides the keyboard. We don't need it anymore, so it just hides it. And let's go ahead and close the sidebar. And then next inside here, we're going to call UI application.shared.sendAction. And inside here, we need to go ahead and call a selector. So hashtag selector. And we need to go ahead and call the UI responder dot resign first responder to nil from nil for nil. And that's all we need to use to hide the keyboard just by using this function. But we still need to go ahead and take care of the functionality inside here. So what we're going to do is go ahead and open this and create a new class. And it's going to be a Swift file. And the Swift file is going to be called converters, because we want this to be a generic function that can be used anywhere in the app. And that just makes it a lot easier to actually test the app later. So go ahead and create a class called converters, and it's going to be a new empty file, of course. And we're going to go ahead and call this converters. And inside it's going to have only one function, which is going to be called convert euro to USD. And it's going to take a euro of type string, so any amount of euro, and it's going to return a string. Now, first we're going to go ahead and hard code the USD rate, which is going to equal 1.08. And we're going to let the euro value equal the double of the euro string. And if the user enters something that the program doesn't understand, it's going to just assign the value of 0 to it. So this will be nil if the user inserts something such as Mario. And if it's actually a real number, it's going to convert it to a double. Otherwise, it's just going to be 0. Now we need to go ahead and cover the potential cases of this function. So let's pretend if the user decides to add a value that is less than or equal to 0, then we need to go ahead and add a case for that. So we're just going to return, please enter a positive number. Now we also want to stop the user from entering numbers that are far too large. So we're also going to go ahead and type in if euro value is more than or equal to 1 million. We're just going to pretend that's a really high number. Then we're going to go ahead and handle that error by returning value too big to convert. Otherwise, we can go ahead and actually return the value that makes sense. So return this interpolated string with a $ symbol. And we want to get the string so that we can format it. So inside here, format. and we want to format it as the following. We want it to have only 2 decimal places, so %.2f, and the arguments is going to be the euro value times the USD rate. So that's going to cover the only function we have, and we're going to make this testable. We're going to create a class that allows us to test it and make sure that everything's running perfectly. But real quick before we do that, let's go to our view model. We're going to go ahead and first create the converter. So private let converter equal the converter class. And next we need to go ahead and call self.convertedText is going to equal the converter, and it's going to convert euro to USD, and we're just going to insert the text. And we also want to call self.hideKeyboard every time we try to convert the money. So we have all of the functionality done, and really we don't even know how this is going to react because we haven't tested it yet. We wrote all the functionality for it, but we don't really know what's going to happen if we insert a 1 or we insert a 10 or we even insert something such as a question mark. We don't know what's going to happen. And this is where unit tests come in. Unit tests just make sure that we can test it a lot faster with all the scenarios possible so that when we actually post it into production mode, we're going to be ready for most of the errors. So actually to create a unit testing project, you just have to go to your main app where you have the general and the signing capabilities and so on, and click on editor. And you want to add a target. And the target is going to be a unit testing bundle. So go ahead and click on that. And you can name it whatever you want, but since this has to do with the converters, I'm going to call this converters tests. And click on finish. And immediately you're going to notice that we're going to have a new folder down here, and this is going to hold some sample functions on creating unit tests. But there's one thing to mention, because we're going to have to try to access the code from the converters, and as it is, if we type in let converter equal converters, it's not going to work because it doesn't even know it exists in this file yet. So we actually have some added configuration, and that means we have to go back to our converters file and open the sidebar. And inside here, we need to add the target membership. So as you can see down here, we have converter tests, and it's important that we tap on that just to let the program know that this over here should have access to the rest of this over here, the converters. And you have to do this with each file that you want to test. So if you have many different kind of Swift files with many functions, you're going to have to do it for each one that you want to test. But go ahead and close the sidebar and open the converters tests. For now, we can just go ahead and take away all of this because we're going to start off with creating a very simple test. So let's go ahead and create our first test. Now, a requirement for creating tests is that the function starts with the word test. So if you want to test do something, you just need to make sure that the function starts with the word test. But for this example, we're going to call it test convert 10. So that's what we expect to insert. And we're going to also type in what we expect it to output. And we're going to say returns 10.80. So for every 10 euros, it should return $10.80 because that is the rate we've specified. So with that being put into place, we can go ahead and get started. Now, the very first thing we have to do in here is create a reference to our converter function. So we're going to type in let SUT equal converters. So now we can actually access that function. And SUT stands for system under testing. And that means whatever you're trying to test, you're going to assign it to this object over here, and it's only a naming convention. Of course, you can go ahead and call this converter if you please, but SUT is just there to tell whoever's testing the project that this part is what we're testing. Now, we want to compare two things. We want to compare what actually happens and what is expected to happen. So here we're going to start with what is actually happening. So let actual equal SUT.convert euro to USD. And inside here, we're just going to insert 10. And next we can go ahead and say, let expected equal the following, which is 10.80. And that's what we expected to do. Or we actually expected to return a $sign as well, because that's what we've specified here is a dollar interpolation followed by the amount to 2 decimal places. So 10 euros should bring us back to $10.80. But let's go back to our converter tests. Now, as you can see up here, we have something that's imported. It's called XCTest, and XCTest comes with a bunch of different ways of testing if something's working or not. So as you can see, as soon as you type in XCT, you're going to get something such as assert nil, assert true, assert false. And it's important you pick the one that fits closely to what you're trying to compare. And the one we're going to try to use is XCT assert equal. So this wants to compare that two items are the same. So here we can type in that actual is equal to the expected. Now to actually run this, you can go ahead and click on any one of these arrows, or you can hold Command plus U. What it's going to do is run your phone, and it's going to perform the test. And if the test goes good, you're going to get a very nice green arrow here telling you that this is exactly what came out and that this test has passed. So that was successfully our first unit test. But for example, let's write something that shouldn't pass, such as 10.80. And 10.80 is wrong because we should have a $sign there. So if we go ahead and actually test this, it's going to run the application and it's going to try to make a test. But this is not going to pass, it is wrong, and it's going to tell us why it's wrong. So as you can see here, it says XCT assert equal failed, $1080 is not equal to 1080. And this is crucial for finding out how our program works, because sometimes we're going to get undefined behavior, and testing just helps us avoid doing that in the future. So go ahead and copy the result you were supposed to get, 1080, and paste it inside there and rerun the program. And what you want to make sure is that you're getting this result consistently. And you might be wondering, well, we made one function here. Does that mean our function is ready for production and that we can actually use it everywhere? And the answer is no. We've just covered one of the many possibilities of what can go wrong here. For example, another thing I want to happen when I use this function is that test that converts -10 returns an error message. And we want to make sure that this actually works. So here we're going to do the same thing as earlier. We're going to copy this part here. And inside here, we're going to type in -10. And we're going to go ahead and remove this because we don't really know what's going to be posted out yet. We have an idea that there should be an error message, but it's a lot of hassle to go ahead and verify this immediately. So here we're just going to leave expected to nothing. And we're going to copy the XC assert equal. Then we're going to go ahead and run this. And it's not going to pass the test, of course, because here we went and created a condition that says if it is under 0, we're going to want to return this string over here. So this is a way of trying to understand what you'll get out, and it's very fast to debug. So you can go ahead and rerun this. And this time the test will pass because we have exactly the error message that's supposed to be output. But it wasn't necessary that you left this empty if you knew exactly what's going to come out. You can easily go to your converters and copy this over here. But for me, it's a lot of hassle to go between screens and test it each time. So I like to run it and know what I'm expecting and then just paste it into the expected variable. Yeah, so here, if we run it again, you're going to notice that we're going to get the positive number we expected, or this error message here, because that's what we defined it to do. Personally, I like to add some messages on top of it so I can understand what it is, because even if it's easy to read this, sometimes it's a lot easier just to read plain English. So don't feel bad if you add a comment there to tell the user or tell the tester what they are seeing, because it just makes it a lot more readable. And the general rule in programming is readability. The better the readability, the easier it is to maintain. The idea is to test a function as many times as you can in as many different ways, so you can make sure that it's going to be robust when you actually ship the app. And in general, we would do this in our content view. We would manually type in 10, 20, -10, but that takes a lot of time as your app gets bigger and bigger. And that's the main purpose of the unit tests. And in general, we follow something that's called AAA, which stands for arrange, act, and assert, which means first you arrange and create all your variables and make sure that everything's ready to be tested. Then you go ahead and act, you actually convert or do the test, and then you assert that it is what you expect it to be. So that's in general how we conduct unit tests. But I want to show you something, because earlier you might have seen there was something called override setup and override teardown, and these are very important methods for our testing. So just above here, we're going to go ahead and recreate those. So override setup with error, and whatever we create inside here is going to be created before each function. And we're also going to create the teardown because those go hand in hand. So function teardown with error. So whatever code we put into the setup is going to be run before each function, and whatever we write inside teardown is going to be run after each function. And this is important if we're creating many instances of an object. We want to be able to create it and we want to be able to tear it down so it doesn't slow down the program and doesn't cause undefined behavior. One example would be here we're creating an instance of converters and here we're creating another instance of converters, and we're doing this many times. And sometimes the memory allocation is not going to take care of that properly. So what we can do with setup with error and tear down with error is make sure that we set that to nil every time we're done with a function so that nothing carries over from the previous one. So an example of doing this would be to go ahead and type in private var sut, and that's going to be of type converters. And we're going to set an exclamation mark because this is never going to be nil. This is just so we can access it in all the functions over here. And then we need to make sure that we actually initialize this. And this is going to be initialized before each time we call a function. And at the end of it, we want to make sure that we set it to nil. So this will take care of initializing it, and this will take care of tearing it down. So we're not going to have a bunch of instances of converters. And because of that, we can also clean up our tests a bit. We can remove this one here and remove this one over here, and our code is going to run exactly as before. Except this time, we don't have to create this for each function we create, and it's going to be torn down each time a function has finished. So if we go ahead and run the code once again, you're going to notice everything's going to run exactly the same as before. But again, anything you want to set up before a function's run, put it into setup with error, and anything you want to run after a function is run, put it into teardown, just to make sure that everything gets initialized properly and everything becomes deinitialized properly. So as I mentioned earlier, there are many tests you can do for a single function, and I'm just going to go ahead and paste them in. So as you can see, the first one we created checks if it's a positive number, the second one checks what happens if there's a negative number. Then we have another one here that says what happens if you enter an empty string. And this just makes sure that if we enter this empty string here, we're still going to get this expected error message. So that's another example of a test. Another one is test invalid input returns error message. So in case you type in hello world, it's still going to ask you to insert a positive number. And finally, there's these two over here that converting a decimal returns a decimal, such as 10.5 is going to return this over here, and converting a million returns an error. So here you can see I insert the number of 1,000,000, and this is what's expected. And if this is asserted to be true, that means everything's going to work perfectly. So if I run the tests from my earlier program, they're all going to pass because it's exactly the same function, but it just tells you that the code has been covered. And I already went through the effort of creating these and testing these, but the idea is to think of as many ways as you can to break your functions, to break your code, and then add a test case that actually handles that. So as I mentioned earlier, this is not the only one you have to use. There's also other ones such as XCT, assert nil, true, false. So use the one that makes the most sense, which means if you're expecting to get a true value back, go ahead and make sure you assert true. Otherwise, if you're expecting to get nil back, make sure you use the nil one. It's important to use the one that most resembles the test you're trying to perform, because then you get the most accurate message back for what you're testing. Personally, I think you're going to be using assert equal a lot, because assert equal is going to compare two things, and if they're both the same, it's going to pass. Otherwise, it's going to tell you that they're not the same. And just to create one more example, we can go ahead and type in test sample test. And in here, all we're going to do is let actual equal true. And what we want to do is type in XCT assert true. And inside here, we just add the actual, and we can choose to add another message if we want, but we're going to skip on that. And we're going to hold Command plus U. And if everything runs successfully, it's going to say the test has succeeded. Otherwise, if we type in false, we can go ahead and rerun this test, and it's going to turn into a small x. And if you actually go over the small x here, it's going to say true assert failed, which means, of course, we got returned a false value. But let's change that back to true and rerun the program and make sure that the test will pass. And one of the major upsides of doing unit tests is that we're testing so many different things at the same time, which means if we decide to change a function later and we rerun the tests, we will also find out if it broke any of our other code. Now, in general, it's very important we try to cover as many functions as possible in our code. So if we go to converters, you'll notice that we only have one function here, but for a project that has many functions, how can we tell how much of the code we've actually covered? Of course, we can keep track of them by hand, or we can also go ahead and tap on the product and click on scheme and edit the scheme. Now inside here, you're going to notice there's something called code coverage. Right under the test debug, there's something called code coverage. And we're going to tap on this box over here, and we're going to gather the coverage for all the targets and tap on enter. Now, if we go back to our converters test and hold on Command+U, it's going to perform the exact same tests, except this time, if we go to this box over here, you're going to notice that instead of just having a log of a build and a log, we're also going to get a box with the coverage. And this provides us a lot of important information. So go ahead and tap on coverage, and you'll notice that inside here, it's going to say that only 71% of our entire code base has been touched. So if we open this box, you can also get a better insight of where it has been touched, such as in converters. If we type in converters, you can tap there, and it's going to say we covered everything. Everything here has been covered, all the lines of code have been touched, which means chances are that we actually did test it. Then we can go back to coverages, and we can also check in the view model. For example, nothing here has been covered. So we can type in here, and you're going to get a lot of red for all the code that has not been touched during this unit test run. So we've never tested any of this. Not that it has to be tested. Some functions don't have to be tested, such as the convert money function is literally just calling another function that we have tested. So that doesn't really matter to us that we actually tested it. And it's also very important that you do not try to get this at 100%. Some things, as I just mentioned, do not have to be tested. And while it's very tempting to make sure you cover everything, it is not completely necessary. But just for starting off, this is a very good tool to give you a very small insight on what has been tested and what hasn't. But still make sure to do your manual checks and make sure everything that should be tested gets checked, because this will just cover all of the code that has been run during your unit test. But it's not always accurate in finding out what you actually tested. So you're going to always have to make sure you do a double check. But I've actually been talking a lot during this video, so let's go ahead and finish the app. So inside our view model, we've now tested this function, and we know that it runs properly because we've created all of the tests that we needed. We can create a few more tests, of course, such as what happens if we enter an emoji or something else. But for now, I believe we've created enough tests for this example. So we can just go to our view model and make sure everything's good there, which it is. We have one convert money function and a hide keyboard function, which is going to be triggered when we convert the money. Now, all we have to do is go to our content view, and inside here, we will create the UI to actually convert the money. And let's close this sidebar. And also, here's another good example. Here, we did not get any code coverage for the preview, but this is not something we have to test. It's always going to be incomplete, which sucks when we're looking at the percent, but in reality, it doesn't matter. We don't care that the preview was not touched, because that's not going to be put into production mode. And also you can toggle this code coverage at any moment in your program by clicking on this part over here and toggling code coverage. So we can remove that if you don't care about that. But let's go ahead and finish this app. So at state object private var view model is going to equal the view model as always. Then we're going to go inside the body and create a form. And at the bottom, we're going to provide some padding. And inside here, we're going to go ahead and create a VStack with a spacing of 20. And I actually meant to put this padding on the VStack like that. So we have this empty box at the top. But inside the VStack, let's go ahead and add a text variable with an interpolating string of ViewModel.convertedText. And the font is going to be set to .headline. Next, we're going to go ahead and create a text field with initial text of enter a value. And the text is going to be bound to the ViewModel.text. And we need to provide a text field style of .rounded border. And then the keyboard type is going to be set to .decimal pad, and the submit label is going to say .done. And finally, let's go ahead and create a button. And the button is going to convert the value, of course, from euro to USD. And the action is going to be the function that we've tested. And that's going to be vm.convertMoney with a button style of bordered prominent. So the UI was super simple to create. As you can see, it's a text field, and a button. And if we go ahead and run the application, we can go ahead and actually test it. We can say 33, convert it, it's going to give us 35 back. We can go ahead and add 33 ... which is invalid, and it's going to tell us to please enter a positive number. Otherwise, we can also try to insert nothing, so convert. It's still going to say please enter a positive number, and you can even insert 0, but that's nothing. We can't convert 0, so it's still going to give the same error message. And we can also type in a big number such as whatever this is and try to convert it. But then it's going to say the value is too big to convert. So we've already gone ahead and done these tests. So we didn't have to test it in the application. We're more or less confident that it's going to actually work because we rely on the function to do the work that we've tested. So to sum up this video, it's actually very important that we have unit testing in mind when we're creating an application, because that just saves us a lot of time in the future when we're debugging or we want to make sure there's no errors, that we've actually tried to cover all the possible errors already there. And I also really recommend you take a look at functional programming, because this just makes it a lot easier to test when you're returning something and when one function is assigned one task. It's so much easier to test because you can check what the result's going to be and you can test it with anything. This function can literally be used anywhere, and it doesn't matter where you use it or what you put inside it. It's always going to be able to convert euro to USD because we've handled all the cases and we've just said that you must provide this if you want to get this back. But otherwise, with that being said, as always guys, thanks for watching and I'll see you in the next video.